The broadcast is now starting. All attendees are in listen-only mode.
Welcome everybody to this webinar on the safety law. That is the publication of the iChemist Safety Center. And today we are going to discuss key lessons from road transportation incidents. Just a quick check. If everybody can hear me, just please give me such a signal in the question box, and then I can continue with the presentation. I guess the audio works well on my side. Thank you so much. Okay. So, perfect. Okay, very clear in Bahrain. That's really good. Okay, this is something different now because the transportation incidents are a little bit different from the process related incidents, but the iChemist Safety Center member thought that it is a significant topic, especially if you think about either the transportation within the company and outside the company, where you have to deal with logistics and you have to carry those dangerous substances, and you always have some cases where something goes wrong. And I would like to give you an overview about this. So this is the seventh safety law. I am the presenter, Dr. Susanna Gyenes, deputy to the director of the iChemist Safety Center. And for those of you who don't know, I will upload the webinar on our YouTube channel, and also it will be uploaded to LinkedIn and our website so that you can reach this webinar later on. And please feel free to share it with your colleagues if you think it has any added value to your practice. And I would also like to take the chance and ask you to type your ideas, your recommendations and thoughts in the questions box throughout the presentation, because it is really, really valuable when you give me your point of view and discuss with others, because I think this is a great opportunity to share our practice, our knowledge in the given topic. And in the last 6 times, it worked really, really well. And I thank you so much for your activity and being so interactive and engaging, so that helps a lot. Now let's start. I always start with the definition, something like to frame the scene and frame what we are going to talk about today. So it is about road transportation. So it's not a ship, it's not a wagon, but it is about road transportation. And transportation of hazardous materials is really, really something that has become more frequent because companies try to deal with logistics, and they also mean and pose an increasing risk. So, for instance, if you think about activities associated with loading or unloading of hazardous materials, and or you think about oh, someone is not receiving any audio. That's everybody else does. So transportation of hazardous materials or truck tankers being involved in road accidents occur quite frequently. As you know that also traffic is really, really heavy nowadays. It's getting heavier and heavier because most of the companies try to deal with their operation in terms of logistics. So they try to solve problems for their operation through logistics. And that's why it is an increasing risk to companies and to people. And these events also need to be investigated to better understand the overall effects of such events and further improve emergency preparedness. You will see in the example about emergency preparedness what you can think about and what you should do about it. So let's start with the first case, and I hope that you will finally hear me. I hope so. If not, then you can see the recording afterwards. I can't fix anything from my side, unfortunately. So it describes this first case describes an ammonia release. It was a very, very hot summer day. A cargo transfer hose ruptured shortly after transfer of anhydrous ammonia. Began from a cargo tank truck to a storage tank. So it's kind of a loading, unloading activity. A white cloud of anhydrous ammonia moved from the parking lot of the facility across the highway to a largely wooded area where it dispersed. At the same time, a car driver traveling on the highway drove into this ammonia cloud, attempting to get away from it, go out of her car, but unfortunately she died. 7 people got slightly affected by the toxic material as well. So on the morning of the accident, the cargo tank truck arrived at the facility. The cargo tank truck arrived at the facility, and the driver and his trainee checked in at the office. They were told to park their truck next to the piping manifold near a designated storage tank. After parking the truck, the driver picked up the vapor hose assembly that was lying on the ground next to the manifold and connected it to the vent line on the cargo tank. Then they removed the cargo transfer hose assembly from the storage tube on the trailer. They checked the pressure valves on the tank and connected the assembly to the liquid discharge fitting on the tank. A plant employee fastened the other end of the transfer hose assembly to the facility piping manifold. The driver then engaged the power takeoff unit, turned on the pump, and checked the tank volume gauge to make sure that the product was flowing. Then he instructed the trainee to oversee the unloading while he completed paperwork in the truck. And approximately 8 minutes after the unloading had begun, the trainee heard a pop sound followed by a loud rush of gas. He looked underneath the truck and saw a rupture in the transfer hose assembly directly in front of him. He pushed the emergency shutdown button and evacuated. The driver also heard the sound, and after turning off the engine to stop the trailer pump, put on his half-face respirator and escaped through the gas cloud. So this is basically what happened. And now let's see what are the key learning points from this case. The investigation found, actually, that the ruptured hose was designed for LPG transfer only, and we are talking about anhydrous ammonia that they transferred. So the hose was designed originally for LPG transfer. It was constructed of several different layers of material, internal fibers made of PET, which was chemically incompatible with anhydrous ammonia. However, it was used to transfer anhydrous ammonia at least 2 to 12 times before it failed. The degradation and final failure were the direct result of chemical incompatibility. Now, the hose for LPG transfer was originally assigned to another trailer, and it was imprinted with text LPG transfer only. The text was not visible on the full length of the hose, only partially, however. The hose, apparently, was not inspected and tested before the accident because it was not considered in service. There was no procedure in place to define what in service means either. The transfer hose for ammonia was carried out on the LPG trailer instead of the ammonia trailer. So when making deliveries, truck drivers occasionally used facility-owned hoses instead of the hose on the cargo tank vehicle. So you can see here that there are a couple of things that reminds us how chemical incompatibility, not following procedures, or just use the same hose by reflex or by practice, or because we always used to do that because it's okay, without understanding what may be the hazards associated with using another hose which was designed. I mean, when you design something that is on a purpose, that was designed for LPG transfer only, it was even indicated. So there are several actually human factors in this case, because of the ignorance of using ignorance of the fact that it was written that it was for LPG only, or the lack of understanding what does it mean, because most probably operators didn't understand the significance of using such a hose that was chemically designed for LPG rather than a toxic material, which is ammonia. So, and yet they used it, and over time there was a degradation in the hose, and then eventually it failed. So 2 to 12 times, it doesn't seem very much, but in terms of when it comes to chemical incompatibility and chemical effects, it is a lot. And lack of inspection of the hose, that was another added factor to this particular accident, and the lack of procedure. And so all of these issues associated with this particular case. Now let's see excuse me, let's see the second case, which is about an LNG road tanker. A tanker having loaded 20 tons of LNG suffered a road accident. Another truck driving on the highway carrying precast concrete panels broke down, and then it stopped on the hard shoulder of the road, partially blocking the lane. 20 minutes later, the LNG tanker collided with the rear of the parked vehicle. Due to this collision, the driver lost control over the truck. It surpassed the parked truck and slammed into the ditch against the 10-meter-high bank of soil. The tanker suddenly ignited just after its full stop. The truck driver died in the accident. When firefighters arrived, they noted that almost all the insulation of the tank had been destroyed by the accident, and as a precautionary action, they evacuated a 600-meter radius area. Flames then appeared on the top of the tank, indicating that the safety relief valves opened, discharging LNG as a jet fire. Within half an hour, the firefighters heard whistles and cracking sound and decided to withdraw to 200 meters. Immediately after this, the tank exploded, creating a huge fireball. The thermal radiation reached minimum 170 meters, and the blast effect reached approximately 125 meters. Now, this is what happened. And let me just give you my personal experience, what happened to us with my colleague when we drove to a company on the highway to complete an inspection. It was a chemical plant, and it has nothing to do with the road accident in front of us that occurred. But while we were driving on the highway, all of a sudden, a truck that carried domestic gas cylinders, LPG gas cylinders, got injured an accident. So suffered an accident. And then all of a sudden, what you could see was that all these gas cylinders were in fire, and one after the other just exploded. And so when we arrived at this accident, basically we were the first ones by chance, but pure chance. And we just remembered from the safety reports that, okay, 11.5 kilograms gas cylinder, normally flying objects, you can calculate approximately like 110 or 20 meters. So then we stopped other cars and then called the firefighters, and it was just really shocking to experience that in life, that you read all these accident scenarios in the safety reports, you see the internal emergency plans and everything in written form. You see the risk contours, the dispersion modeling, the blast effects and everything. But then when it comes to life and it happens in front of your nose, then you all of a sudden you realize that, oh, okay, so the projection can be like over 100 meters. And I'm pretty sure that you also seen many of these videos, because I also saw them on LinkedIn, where these tanks are just like flying objects. They are flying everywhere, hit everything around. So that is the emergency preparedness or emergency response, that you have to keep the safety distance, even if you are not the one who actually part of the emergency response team, but as a precaution. And as we know that people normally come to the scene as spectators, and all of a sudden they pick up their mobile phone and try to record everything and post it on whatever social media. So that is also a practice that is associated with such cases. Now, I just wanted to tell you the story because it was quite a shocking event for me to realize in real life that this can happen, really. So coming back to this LNG road tanker accident, I would like to highlight some of the key learning points. Even though the tank was insulated with polyurethane, the accident demonstrated that both the road accident impact and the fire can destroy the insulating layer. An important factor is the possibility of flames impinging on the tank wall. If it takes place above the liquid level, the wall temperature will raise, and even if safety valves are correctly operating, it is possible that the vessel cannot stand the pressure and explosion can occur at any moment. The impact of such event can be very serious, both in terms of the blast effect and the thermal radiation. That should be considered when intervention starts by firefighters. I'm pretty sure that you may have more learning points from such cases that you've come across in your operation or in your practice. And if you want to share them, please just type them in the question box. It's researching this kind of learnings was quite difficult, I must be honest, because I haven't found really thorough investigation reports on such road accidents. And that was quite a big challenge for this particular safety law. It's not like the previous ones on different topics such as aging or creeping changes or flanges and flare systems. This is something different. And we now arrived to the part where I discussed the What Can I Do session. And in particular, today, this is about what can I do as a manager, what can I do as a supervisor, and what can I do as a driver or operator, and some aspects of the emergency response team, because it is always really important to highlight the emergency response, importance of the emergency response, importance of emergency response plans, and so on. And this is all around the 6 pillars, the 6 elements of the iChemist Safety Center's framework: systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. And when you download the PDF version of the safety law, which is available both in English and Spanish, then you will see that all these recommendations are associated with one or two or a few of these colored dots that actually represent each element in this What Can I Do session. Now, let's come first, what can I do as a manager in such cases? So make sure that risk assessment is carried out for loading, unloading activities within the facility. I think it's quite obvious, isn't it, from practice? It's nothing new, it's nothing novelty, but I wanted to highlight it because maybe it is forgotten. I don't know, maybe not. When design a new loading, unloading station, bottom loading is preferred to prevent falls from height during tanker loading. It also often provides quicker and safer escape routes than top loading. I wanted to add this as you know that the What Can I Do session not only refers to the case studies before that I analyzed and drove those key learning points, but they are coming from other background information, literature, and sources of information. Make sure that operating procedures and regular trainings are provided to tank truck drivers. Loading bays should be equipped with alternative escape routes with emergency stop buttons. For toxic materials, automatic emergency shutdown should be in place. So what can I do as a process engineer or a supervisor in this case? Make sure that the operator is conversant with the task, understanding the hazards associated with the particular activity, the risks, and the consequences of getting it wrong. So they have to have a basic understanding what could go wrong, what is wrong with using the LPG hose for loading ammonia, sort of things, so that they have to understand what they are doing and why they are doing it, and why they are doing it in that way, in that particular way, and whether they are sure that they check the procedures or they are following the procedures, and in fact, if there is a procedure in place. So this is for everyone basically, but I put it here in the process engineer and supervisor session. Make sure that loading stations are equipped with dry decoupling protection or physical barrier to prevent drive-aways. I'm pretty sure you have seen thousands of videos of this when without decoupling, the truck actually left the loading unloading bay. And all of a sudden, the material that was loaded or unloaded, all of a sudden it caught fire, and then it was released, and those occasions, I've seen some of these, and this is still happening. Make sure that the wrong hoses are not available to use via selective couplings or dedicating loading areas. So there is an LPG loading area for LPG, and so on. Make sure that personnel working within the transfer zone or near the tank during filling wear individual protective gear appropriate for the type of hazardous material being delivered. Ensure that the system is checked or functionally tested before use for hose integrity. Check if a suitable spill kit available for emergency use and that operators trained in its use. Ensure that hose assembly is subject to the maintenance regime. Suitable maintenance is completed and that integrity checks are done. What can I do as an operator or a driver? Make sure that you follow operating procedures when preparing and conducting loading or unloading operations. Make sure that the transfer hose assembly is the correct one to connect to the tanker storage tank to avoid chemical incompatibilities and potential release due to inappropriate coupling. Check if flexible hoses are the correct ones, color-coded, selective, or clearly identified. For example, for correct materials of construction and correct end connections to suit tanker and plant. Check if the hoses are in good condition, not kinked, twisted, elongated, or damaged. Moving a vehicle while it is loading product or driving away with the hose still connected can have serious consequences. And make sure you communicate clearly when a loading or unloading operation is ongoing to prevent truck moving from the bay prior to the end of the filling. So what else, as an operator or driver, you can do? Earth, ground, and bond tanker or road truck equipment and containers to prevent static charge buildup. Drivers, deliverers should make sure that they are familiar with the emergency shutdown system in place, emergency warning, and access to emergency exits. In case of a road accident, make sure to set up appropriate safety distances and evacuate people from the vicinity of the release of hazardous materials from the tanker. and this is part of the emergency response team's responsibility as well. But the driver, if he or she survives the accident, they must be aware of this as well, that they should evacuate as quick as possible. Carrying a loaded truck is a very dangerous activity, and as such, be aware that you take all precautionary measures to follow the highway code to prevent road accidents. Make sure you receive trainings on risks related to transferred product, safety procedures, and what to do in case of an emergency. Ensure the vehicle maintenance log is up to date and inspect the vehicle before driving it. Drive at a suitable speed for the task, ground or weather conditions, and at a slow enough speed to stop safely. So these are a couple of ideas, but I'm pretty sure that there are more available in practice. So I would be really happy to see them in the question box if you want to add some of your thoughts and ideas. And I think something like what is it called? I need your help with this. I think it's called a human or operator proof coupling, so that they cannot actually link the hose or assembly the hose which is not compatible, chemically not compatible with the one that they want to use, so that they avoid such a situation when they can couple with such a hose that is not the correct one. Something it is called like that, but I don't remember. I need your help with this if you don't mind. And now I would like to give you the source of information for the safety law. It's not only in PDF format, but also in MP3 format as a podcast. It is available to download. It is a podcast that we recorded with Trish Kerin, the director of the iChemist Safety Center. We talk about the law, and so you can listen to that as well, and you can find later on this webinar uploaded to the LinkedIn and YouTube channel as I promised. And here is the slide with our contact details, and please feel free to send your questions and inquiries or ideas, thoughts to the safety center at ichemi.org email address. You can find us on www.ichemistsafetycenter.org and in many different social media platform. And this is you can see also the LinkedIn, Instagram, Twitter, Facebook, YouTube channel. So let me see your questions and suggestions. So, okay. Someone actually gave me another accident case, so I am happy to send it out to those who are interested in it. And thank you so much, Amanda. So this is another incident where not keeping appropriate safety distance after accident hurt a lot of people. This is really interesting, and this occurred in Australia. Okay, I am very happy to send you out this link after the presentation if you are interested. Man-down switches can be installed to ensure 100% surveillance of filling operations by the operator to prevent overfill of tankers. They can be linked automatically to emergency response alarm to notify others. Okay, there is another case, LPG tanker crash in Ruad under highway bridge, Ruyadh. Okay, Riyadh. Oh, Riyadh. Okay. Okay, Riyadh, under highway bridge. Thank you, Andrew. Okay. Do you happen to know that the time I was talking about basically the foolproof coupling, so that you can't even assembly one hose to the tanker that is not the appropriate one, because I don't remember now how it is called, but it is a really simple way of solving the problem when operators want to assembly one hose to a tanker that is not compatible with it. or the size. It can be solved with the size of the hose. Anything else you would like to share or you would like to ask? Please just type it in the question box, because this was my part about transportation accidents in brief. And thank you for the information. And if there is no other question, then foolproof connection, that is, yes, thank you. Having a foolproof connection is called poke-yoke in continuous improvement terms. Is it Chemlock fittings that prevent incorrect connection of incompatible services such as caustic soda and sodium hydroxide? Is it? I don't know. Chemlock fittings. If somebody feels that you want to reply, then just feel free. Caustic and sodium, yeah, acid. So Chemlock. All right. If you have additional thoughts, as I mentioned, just send an email, and I'm very happy to respond if I can. So thank you so much for your attention, and thank you again for coming to this safety lore, even though this is Tuesday today. Product specific couplings, different for each product. Yes, thank you. That is a really good recommendation and idea. So thank you so much again, and hopefully we meet again next week. And I think it will be on Monday at our regular day. Thank you so much. Bye bye.